In this lesson, we're going to take a closer look at isosceles and equilateral triangles. So please remember from section 4.1 that an isosceles triangle is a triangle that has two congruent sides. What we didn't learn in section 4.1 though is that isosceles triangles have special names for their sides and for their angles. So if we look at this picture right here, there are two sides that have the tick marks on them, which would be the two sides that are congruent. Those are called the legs. So we have two legs, one here and one here. And then the sides, the one remaining side that's not a leg is called our base. And so what's important about the sides are that the two legs will be the same measure, but the base will not be equal to either of the legs. So you have two sides that are the same size and then one side that is not. If we look at the angles instead, we have an angle called the vertex angle, and then we have two base angles. So if I come down here and kind of highlight these in red, those are considered your base angles. And how do you know where the base angles are versus the vertex angle? So if you trace, let me trace in a different color. If you trace the legs, let me trace these in blue. And I know that's a leg because it has a tick mark. And let me trace the other one. That one has a tick mark too. If you trace those, they're going to meet, and notice how they meet here, up here at the top. They're going to meet at the vertex angle. And then notice as you go down on the blue leg, they separate, right? The places where they separate are considered your base angles. So if you see where I highlighted those two legs in blue, where they meet up at the top is called your vertex angle, and where they spread out and separate, those are called your base angles. So what's important about an isosceles triangle is that the legs are congruent, but also the base angles are congruent. So if you look at these pictures here that I have with the arrow between them, it's saying if what you know is that the two legs are congruent, then you can also conclude that the two base angles are congruent. It doesn't matter how the picture is marked. If it's marked with the legs, then you can assume the base angles are congruent. And really, this triangle should have had the same letters, so I apologize for that. Okay? All right, so let's go down and look at some examples. In example 1a, they want me to solve for x. And so if you look at this picture, you have to ask yourself, is x a base angle or is it a vertex angle? And so again, if we want to trace those legs in blue, I'm going to trace well, that's not blue now that it really matters. Let's trace them in red. If I trace this one side that has a tick mark in red, and notice the tick mark on the other side, I'm going to trace that one in red. So the angle at the top where they meet up right over here, this is considered your vertex angle. The other two angles where the red sides spread out and they don't meet up, those are called your base angles. And so my base angles are congruent. So x is going to be equal to 52. So base angles are congruent, and the vertex angle is not congruent to the base angles. So in example 1a, I had a set of base angles. Now in example 1b, if we look at 1b, they want me to solve for x, but again, I have to ask myself, is x a vertex angle or a base angle? So if you trace the sides that have the tick marks on it, they are meeting up at the top. That means that up at the top is your vertex angle. So what we're going to do with this picture then, we know the base angles are congruent. So this angle and this angle are going to be congruent. So we're going to put a 42 degrees over here because those two angles have to be the same. And so in this case, the way we're going to solve for x is we're going to use that rule that we learned in the last section, that you can add up all three angles in this triangle and set it equal to 180 degrees. That is true of all triangles. If you add up their angles, it will equal 180 degrees. And so if we solve that, we'll get x plus 84 equals 180. If we subtract 84 from both sides, we'll get x equals 96 degrees. So our missing vertex angle is going to be 96 degrees. All right, in the next picture, if I look at that picture, again, let's see what they want me to solve for. They want me to solve for x. And if I look at the sides that have the tick marks on them. They're meeting at the top, so 38 degrees is considered my vertex angle. So the angles that are going to be congruent are these two at the bottom. And so if one of them's an x, if angle B is an x, then angle C must also be an x. So in this case, again, what we're going to do is say the x plus the other x plus the 38 is going to equal 180 degrees, because triangles always add up to 180 degrees on the inside. So this gives me 2x plus 38 equals 180. And if I subtract the 38 from both sides, my 2x is going to be equal to 142. And if I divide by 2, my x will be equal to 71 degrees. So that missing x at the bottom is a base angle, and it is equal to 71 degrees. So it's super important that you understand which angles are the base angles and which angle is the vertex angle. The vertex angle is not congruent to any other angle, but the base angles will be equal to each other. All right, so if we keep going with this example, in D, it says the measure of angle 2 is x plus 60. So again, let's trace the sides that have the tick marks on them. Where those two red sides meet up is up at the 80, so the 80 is the vertex angle. So the measure of angle 2 will be equal to this other side, right? So they said the measure of angle 2 is x plus 60. So that means the other side is x plus 60. And so we can now add everything up. X plus 60 plus the other x plus 60 plus the 80 is equal to 180 degrees. Again, the inside of a triangle will always add to 180 degrees. So if we combine our like terms, x plus x is 2x, and then 60 plus 60 is 120 plus 80. So again, add up your variables and add up your constants. So 120 plus 80 is 200 degrees. That equals 180. Subtract 200 from both sides, and we'll get 2x equals negative 20, and then divide by 2, and your x is equal to negative 10. All right, so again, you had to decide which two angles were the same and which one was different. The vertex angle will always be different, and the base angles will always be the same. All right, finally, one more example. In example E, it's asking us to find angle 2. Again, if you trace the sides that have the tick marks on them, they meet up at angle 2, or actually in this case, they meet down at angle 2. So wherever they meet is the vertex angle. That is not congruent to anybody else, right? This is going to be 8x, but the other two angles will be congruent to each other. So make them both 50. If one of them's 50, they're both 50. And so we add everything up. 8x plus 50 plus the other 50 equals 180 degrees. 8x plus 100 equals 180 degrees. Subtract that 100, and we'll get 8x equals 80. And then we'll divide by 8, and our x will be equal to 10. And if you ever wanted to kind of do a little sanity check and say, did I solve that right? Think about this one especially. You could go and put that 10 up next to the 8x, right? 8 times 10 will give you 80. And 80 plus the 50, so this 80 plus this 50 plus this 50, that gives you 180 degrees, which all triangles add to 180 degrees on the inside. All right, so that's notice in these, what we knew to be true was we had two congruent sides. Every single picture here had these tick marks on the side, right? They all had tick marks. And so that means they were isosceles, and that means the base angles were congruent. In example 2, I don't see tick marks, but I see arc marks. So I'm seeing these arc marks down here. So remember that those are considered your base angles. So the two sides that are kind of meeting down at the bottom like that are the the 2 I just put tick marks on. Those are called your legs. And your legs are always congruent, so the x must be equal to 7. They're both going to be the same. The way that could look a little trickier is if we look in B. At example 2B, we have a 2x plus 16, we have a 4, and we have a 10. We're definitely going to set 2x plus 16 equal to something, right? But we got to figure out what. Am I setting it equal to the 4 or am I setting it equal to the 10? So again, think about those 2 legs if we highlight them. The 2 sides that we highlight have to both touch those base angles. So notice how the 2 red lines that I highlighted, they spread out to where the arc marks are. So these are considered your legs then, the ones I just highlighted in red. So our 2x plus 16 is going to be equal to 4. We're going to subtract 16 from both sides. We're going to get 2x equals negative 12. And then if we divide by 2, we're going to get x is negative 6. All right. So in this case, they marked the base angles, and I had to figure out, well, where are the congruent sides? Those are going to be the ones, again, that spread out to meet down at those arc marks. And so those will be congruent. All right, so that's isosceles triangles. Let's move on to equilateral triangles. Now, we should remember that equilateral triangles are also automatically equiangular, which means equilateral means they all have the same side lengths. Equiangular means they all have the same angles. And so in an equilateral equiangular triangle, all the sides will be congruent and all the angles will be congruent. And if all the angles are congruent and the whole triangle adds to 180, that means each angle must only be 60 degrees. All right? So in this first picture, we have a bunch of tick marks, right? We have a bunch of tick marks. That means all the sides are congruent. And then, of course, that automatically means all the angles are congruent. So we should have 3 arc marks too. So notice how everything's marked. All the sides are marked and all the angles are marked. And they're all marked exactly the same way. The sides have the same marking and the angles have the same marking. That means you know you have an equilateral equiangular triangle. So again, this picture here really should have had an A and a B and a C on it. I messed up there. But what this is trying to tell you, this picture of these 2 triangles here with the arrow in between them, it's trying to tell you that if all they tell you is you have 3 congruent sides, you should also know that that means you have 3 congruent angles. And that arrow, that black arrow, is going both ways, because it means if instead they tell you, this first thing that they tell you is that you have 3 congruent angles, it means you should automatically know that you also have 3 congruent sides. So if you know one, the other one is also true. Okay? So equilateral equiangular triangles are actually pretty easy to solve, because we know that every angle is 60, all the sides are the same, and all the angles are the same. So in example 3, because I see these 3 tick marks, I should know that means there's also 3 arc marks. And so if one angle is 60, that means they're all 60. So even that missing x is going to be 60 degrees. In example 3b, they are all 60. I mean, I know this is 60 right there, right? And this is 60 right here because of these 3 tick marks. However, I'm supposed to be solving for x. And so angle 2 was down here in this bottom corner. Angle 2 is x plus 67. But I know that's equal to 60 because all the angles are equal to 60. So if I solve that, x plus 67 equals 60, and subtract 67 from both sides, I know that the x must have been negative 7. So if I plugged in a negative 7, where I see x plus 67, I know that means I'd get a 60-degree angle. All right, and the difference, what's happening with number 3C, is that notice there's no 60 degrees. In the other 2 problems, if you look at the original problem, there was a 60, there was another 60. There's no 60 in example C. But that's because they don't need to tell me there's a 60-degree angle. If they tell me I have these 3 tick marks here, I automatically know that I have 3 congruent angles, which means I automatically know everybody's 60. And think about why they all have to be 60. Because the whole triangle has to add to 180. So if the whole triangle has to add to 180 and they all have to be the same, that means each one's 60. So the equation I can write is that 3x plus 15 must be equal to 60. And notice how that 3x plus 16 is pointing to the inside of the triangle. Also notice how it has a degree mark down here. So that's trying to tell you, even though they can't fit it inside the triangle, they're trying to tell you that angle C is 3x plus 15. And that's why they're pointing inside to it. All right, so if we solve this, we get subtract 15 from both sides. We get 3x equals 45. We'll divide by 3, and our x will be 15. Okay, so every angle in an equilateral equiangular triangle is going to be 60 degrees. So it makes them very easy to solve. Now the sides, also, the sides are super easy to solve. So if you look at example 4 and think about what's marked, what's actually marked is all of the angles. But what are they asking for? X is actually outside of the triangle, so it is labeling a side. So they want me to say what is the measurement of that top side that has an X on it. Well, if it's equiangular, it's automatically equilateral. So if one side is 9, which I see down here, one side is 9, that means the other sides are all 9. Even that top one is going to be X equals 9. So it's not very easy to make the equilateral triangles difficult. They're pretty straightforward because all the sides are equal. So even in example 4b, all the sides are equal. And I know that because these 3 arc marks automatically imply that all the sides are equal too. And so really all I'm going to do is take x minus 1 and set it equal to 11, add 1 to both sides, and I get x equals 12. So to recap, in an equilateral equiangular triangle, all the sides are congruent and all the angles are congruent, and each angle is 60. And you can use that information to solve for missing sides and missing angles. In an isosceles triangle, 2 of those sides will be congruent, and those are called our legs, and the base angles are also congruent. And remember that the base angles are where the legs spread apart, not where they meet up. Where they meet up is called the vertex angle.